Well, hello everyone. Um, Back here with another video for the ITS2300 data networking class, or anyone else who's interested in this topic. So our chapter or our topic for this video is the domain name system. And as always, take a quick look at the content of our the book we've been following, the TCP Illustrated Volume 1 by Stevens and Fall. In this case, the DNS is described in Chapter 11. Again, for the understanding at the level that we're interested in, what's super important is the first part of the chapter. The introduction, the namespace that talks about how the domain name system is organized, the servers and the concept of servers and zones. It's pretty safe to probably skim the caching section. Don't get caught up in the details there. The introductory section of the 11.5 is also, and I'm checking here off screen a little bit so I can make sure I get you the right information. The 11.5, the introduction, the first part of section 11.5 here. That describes the core of how DNS works. So really important. It's not terribly long. It's not super short either, but really worthwhile reading very carefully, as that describes exactly how DNS operates. After that, it is pretty safe to skip pretty much everything else. I would say 11.5.6 that talks about resource record types is probably worthwhile looking at. That's because while we use DNS traditionally to help convert names to addresses, I can store a whole bunch of other things in DNS and look it up by name, or even retrieve names given addresses or other types of lookups. So that one's worthwhile looking at. Everything else is really very quickly into sort of the details of a DNS operation. And the DNS protocol when it comes to how to implement it, how to administer it at a very technical level that goes beyond the scope of what the class or these videos are about. Right. So as usual, I'm going to try and see if we can just do a little bit of a summary here. Obviously, doesn't replace either lectures or reading the book, but couple of things that are important to note here, and so I want to touch on those if I can. The DNS system is often described as distributed, and I'm already getting myself into trouble here with my drawing skills. The problem DNS had to solve, and DNS of course stands for the domain name system. The problem DNS had to solve is that no one entity can conceivably manage the entirety of all the information that needs to be stored in DNS. Right? The addresses and all the other information for every device that's listed in DNS across the world, that will be impossible. So it has to be administered locally. An organization that runs a network has to enter and update information about its own domains, DNS domains, its own servers, its own addresses. How do I do that and yet still create a whole system that works properly and works as if it was one homogeneous system when in reality it isn't? And there's two pieces to that. The first one is technical, and this is sort of where the DNS protocol section comes in. Right? We have a number of servers, name servers, and name servers are authoritative for some portion of the DNS namespace. It's called the zone. So let's pick on a server that actually exists at Ohio University in my department. It's a server that answers to ion.its.ohio.edu. And in theory, even though nobody ever writes it, there's a dot at the very end here. We read this name right to left. So starting at the unnamed so-called root of the namespace, this particular address is in the edu zone or top level domain. Within that edu domain, it is in the ohio.edu domain, and within that it is in the its.ohio.edu subdomain, and it answers the name ion.its.ohio.edu, which is housed in the its.ohio.edu namespace or zone. All right, so each of these represent and each of these pieces can be administratively administered in different places, and this is where the distributed nature comes from. All right, so there is an entity that operates the name servers that understand that have top level knowledge of the edu domain, so they know a little bit. They know where the ohio.edu name servers are located, but no further content. So if a name server queries for this name, it will first of all start, if it has to, it will start with the so-called root name servers, the ones that serve the very top of the namespace. These are hard-coded into the DNS servers that try to resolve names. Sometimes called DNS resolvers. So the root name servers are hard-coded into the software that tries to do this. That just does the name lookups. If necessary, the resolver will send this name to a root name server and it gets back nothing other than a list of name servers that are knowledgeable or authoritative for the edu domain, top level domain in this case. So the dot is the unnamed root domain, edu is a top level domain. All right, so if I have a list of edu top level domain servers, I can send, and again, I don't break this down because I have no idea where the boundaries are, so I always send the entire name to the next name server. So having sent it first to the, I guess maybe I should mark it here. So having sent it first to the root name server right there, I got a list of edu name servers. Now I'm going to ask the edu name servers. They'll come back and give me a list of servers that can answer for ohio.edu. It's a subdomain under the edu domain. And again, all I got back was a list of name servers. I didn't get an answer. And then in this case, the ohio.edu name servers are also authoritative for the its.ohio.edu zone. They wouldn't have to be. So it is possible under other circumstances. It would be possible for this to go one step further, and the ohio.edu name servers could respond with, here are the its.ohio.edu name servers, but that zone is housed in the same servers as the ohio.edu zone in this particular example. So the ohio.edu servers will actually return an answer, but they could redirect. They could direct me to yet another level of indirection to an its.ohio.edu server. In fact, at sometime in the past, that's how things were organized. My school was actually running its DNS separately. All right, so that's how this technically works. All right, so I have a chain of name servers that are linked, so I can always work my way from the root domain, from the rightmost dot. I can work my way over towards the left to the more specific zones, the more specific subdomains, and ultimately to the name. I can work my way through that there, right to left, and eventually get an answer if everything's configured correctly. Right, and so the end user, by the way, so my workstation here would never see that because it would ask a caching name server, would ask a name server, in this case something I run here at my house, to get the answer for me, and it would go through these steps and eventually retrieve an answer and give it to me. So I would never see this. There are some tools that we use in the lab in ITS in the ITS2300 class, where we actually force the PC that we're on to do this. Do it by itself, so we can actually see the various steps. But normally you don't see that. Right. So what this means is that there's really no. Again, this answers the question. There's no one outside of Ohio University has to know anything about the content of the Ohio.edu name servers. The only thing that we have to do is make sure that Ohio University, in this case, registers its name servers into the edu name server so that this chain is unbroken. So that if I start with the root, at the root, this process properly works its way from the top level down to where the name can be resolved. Which gets us to the other half of this, right? I need to administer this. I need to make sure that this actually happens. And so, there have to be there has to be a way for Ohio when we first got that domain to say, okay, we want Ohio.edu. It's ours. Nobody else can use that name. Here are our name servers. Please register them in the edu name servers so that somebody can find us. How does that actually happen, right? And the answer to that is that we have an international organization called ICANN, International Corporation for Assigned Names and Numbers. In this case, we're interested in names. That sort of writes the rules and operates some of the very high level politics and policy around this. And then I have two entities that are unfortunately super similar in name. So somebody has to be responsible for operating the things like the edu top level domain, in the sense of knowing which subdomains are registered in it, which ones are valid, like ohio.edu, and where the name servers are, so that, and to operate name servers can hand out that limited information so that linkage exists. That is called a registrar, a registry. I keep getting myself mixed up. This is called a registry. So the registry will, for example, the edu registry will make sure that edu name servers exist and that they have the correct information, in particular the information about where the name servers for all the subdomains are: osu.edu, ohio.edu, msu.edu, whatever. All the different universities are that part of that top level domain. ICANN has two roles here. First of all, they have to they write the rules that basically determine what top level domains are valid. And some, like edu and com, are very old. They've been around for a long time. There's some really new ones like .beer and .ninja. I picked up profcruise.ninja a couple of months ago. I haven't really noticed what the purpose of that was, but it was unlimited access, and so I got a name in it. So ICANN will certify registries and also govern what top-level domains are actually valid and entered into the system. And then the other half of this is an entity called the Registrar. The Registrar is the customer-facing interface. So if here's a customer who somebody wants to obtain a domain name, they contact a registrar. It could be companies like GoDaddy. I use Namecheap.com. There are many others. The registrar will interface with the customer, get the customer's information. Query, look at the various databases to make sure the name they're trying to get is actually available. And if it is, they collect information about where the name servers are going to be from the customer, and then transmit that to the registry so it can be put into the system and make the whole system work. All right, so this was a really super quick overview of DNS. And obviously not intended to stand by itself, but a little bit of a guidepost for reading in the book or any other book on DNS, and hopefully give some basic understanding of how the system is supposed to work. So as always, I hope this was useful, and I will see you in the next video.